Okay, folks, let's talk about lesson 1-4, section 1-4, that is, continuity and one-sided limits. All right. Today you'll be able to determine, and you can read that on your own. All right. Let's first look at the warm-up. It says, identify which x values you think may cause us trouble. Well, if you look at it, in most cases, the ones that will cause us trouble are right here. -4, +2, and +4. So I got -4, +2, and +4. Now for the second part of that, it says to evaluate each of the x values in 1. So let's do that. So f of -4, if you look on here, f of -4 is +3. Just as f of 2 is going to be -1. And finally, f of 4, as you look, does not exist. And the reason it is because it's open. All right. So then for number 3 of the warm-up, it asks you to determine the limit at each of the x values. So let's do that. So at x, when x approaches -4, the limit does not exist. And it does not exist is because there's a break. And at +2, when x approaches +2, it also does not exist. Once again, because of a break. Now, finally, the last one, as x approaches 4, the limit is actually +2. And the reason is because from the left, it approaches +2, and also from the right, it approaches +2. So both the left and the right, it approaches +2. Therefore, the limit does exist at that point. Even though the function value does not exist when x equals 4, the limit of it does exist. All right, so we're going to talk more about that as this chapter or as this section goes on. All right, here's what you need to know. A limit from the right is indicated by a C positive. Limit of the function of x equals L, where C in the limit are elements of the reals as x approaches C plus. Now it says plus here, but it means from the positive side or from the right. When I say positive side, I'm talking about the positive direction, which would be the right side coming from the right. And from the left is indicated by a C with a little negative sign up in the top right corner. So what we have to get at is you have to take the limit from both the right-hand side as it's coming towards from the right and also from the left. Okay, now let's look at this example right here. Here we have the function of x equals the square root of 9 minus x squared. All right, now, when we do this, the curve is going to look something like this. Now, these aren't exact here, so just kind of have to bear with me on that. All right, now, here's what we know. This is -3. This is 0, and that's +3. The limit of f of x as x approaches -3 from the positive side means it's coming from right there. It's approaching there. So that limit there is going to be 0. Now the limit from as x approaches -3 from the negative side is, you look here, there's nothing over here. So it does not exist. Nothing there. Okay, so if it's 0 from the positive side and negative and does not exist from the negative side, then that means we have two different limits. If we have two different limits, then overall the limit at this number does not exist. And it does not exist, but if I ask you for the function of -3, when I plug it in, its value will be 0. It'll be 0. All right. Now, that's that. So you got to remember, limits coming from the positive side or the right and limits from the left. They have to be equal. And we'll talk more about that as the section goes on. Okay. Next, we're going to talk about continuity. Continuity at a point. A function is continuous if at any value of c, where c is any number, if all three of the following conditions are true. First of all, f of c is defined. That means that there is a value, that it does exist. So like say f of x. If f of x does not exist, then that means it's not defined, which means that the first one here does not hold true. Next, does a limit exist? And then finally, does the limit and the function exist? Meaning that at any point right here, you can see that at this value of c, the hole is filled in and the limit is the same on both, coming from the left and coming from the right. So, and I'll come back to that in just a moment. But the existence of a limit, let f be a function and let c and l be elements of the reals. Here's what it's saying. The limit will exist as long as the limit from both the positive value or positive side and the negative side are both equal, meaning that coming from the left and coming from the right, they're both equal. Now, examples is, just a moment ago, we did this example. From the left, this value equal, the limit was 3, but down here, coming from the right, the limit has a value of -2. That is not the case. Therefore, the limit does not exist because it's not the same on the left and the right. And that is what this statement means right here. Now, let's go back to this for just a moment. All right, so an example of this is right here. I'm just drawing you one. Okay. Here, at this value of c, f of c is down here, but the limit as x approaches c is way up here. This is one example of does not exist. On the other hand, the limit and the value of f of c do exist, and they're the same thing, and they're both equal. So, from right here, and I'm going to highlight that right there for you. All right. Now, put the definition of your own words. I'll read it through for you. A function is continuous on a closed interval from a to b if it is continuous on an open interval from a to b. And the limit from the positive side and the limit from the negative side are both going to be equal to one another. All right, now, let's try this example real quick, and I'm going to show you how this is different. Okay, number one, is the function continuous on the open interval from -3 to +3? And we'll talk about that. This is what it will look like. The curve is going to look like that, but it's going to have an open dot on both sides. Is it continuous on the open interval? And the answer is no. It is not, because it is not open. It is not open. It is open, excuse me. It is not closed. Since it is not closed, then that means the limit from the left and from the right is going to be different. So that's an example of when it is not continuous. Now, if I took the same one and I closed it, now that it's closed, yes. Okay, it is a closed interval. Because it is closed, we can now say that it does have continuity from the closed dot of -3 to +3. All right, now let's do some more. Okay, and actually one thing I'm going to do here is the following. I'm going to pause this because I'm going to be... So let's stop this right here.